Now, yes, voice is clear. Is my screen is visible or not? Technical check I'm launching. Just respond to the polls whether my screen is visible clearly or not, and my voice is clearly audible or not. Yes, everyone. Is my voice clear to all, guys? Now it's clear. Yes, right. Thank you. Thank you all. Thanks. Okay, I'm ending it. Sure. So in the previous class, we have studied. Okay, just wait for 2 seconds. Okay. So hello everyone, welcome to the class. And today we are going to start from the equation of. Okay. So in the previous class, we have already studied what is how we can find the equation of tangent at a point to the circle. Yeah, that is these things. This is my point of contact. So in the previous class, we have studied already. Slope form is this, and this is my parametric form of a tangent, and this is my point form of tangent. Okay, t is equal to 0. What is t? Now, when you will put the given point in the left-hand side of the given equation, then it becomes t. And if t is equal to 0, that is my equation of tangent, right? Okay, so now start from how we can find if you have an external point and you are asking to find the equation of tangent from that point to the circle. Suppose you have a point here P and whose coordinate is x1, y1, and you need to find the equation of this tangent, blue color line, okay, equation of this tangent to this circle. Is that clear to everyone? Yes. Suppose equation is given like this: x square plus y square plus 2gx plus 2fy plus c is equal to 0. Is that correct? Okay. And you need to find the equation of tangents. So if you have the equation of circle, then you know what is the center. Yes, easily you can find the center coordinate of center also, and you can find the radius also. If my radius is r, where r is equal to under root of g square plus f square minus c, right? If you have r, and if I'll let's take the slope of the line or slope of this tangent is m, then you can easily find the equation of tangents. So how you can find the slope of the line or slope of the tangents? By using the perpendicular distance from the center to this line. Then from here you will get the slope or m. So if the line having the slope m and the point x1, y1, then the equation of the tangent will be y minus y1 is equal to m into x minus x1. Yes or no? So let's solve one question, then it will be clear to all, right? So let's solve. So here you have a questions. You need to find the equation of tangents to the circle. The given circle is this from the point 0, 1. Okay. Suppose you have a circle here and you have a point that is point 0, 1, and you need to find the equation of tangent from the point 0, 1 to this circle. Suppose this point is P and this is 0, 1. Then what is the radius of the given circle? That is under root of g square, under root of g square plus f square minus c. Yes or no? So what is g here? 3, right? 3, 4. 3, 4. That is 3 square plus 4 square minus 0. We don't have any c here. So that is 3 square is 9 plus 4 square is 16. 16 plus 9 is 25. So 25 and radius becomes 5. So here I'm getting the radius is 5. Okay. Suppose this is my center. Now what is the coordinate of center? That is 3 minus 4. Okay. 3 minus 4. Now you need to find the, suppose I am taking the equation of this line tangent is m. Then can you tell me what is the equation of line which having the slope as m and the passing through the point 0, 1, that is y minus 1 is equal to m into x minus 0, that is mx. So here you are getting the line as mx minus y plus 1 is equal to 0. Suppose this is the equation of tangents and you need to find the m. How we can find the m? Now we know what is the perpendicular distance. We can find now the perpendicular distance from the center to that line. Yes or no? Yes, we can find easily. How we can find? This is my line. Mx minus y plus 1 is equal to 0. And the point is 3 minus 4. Yes, my point is 3 minus 4. Right? Okay. So let's find the perpendicular distance, that is m into 3 plus or minus of 4, that is plus 4 plus 1 upon root of 1 plus m square, right, which is given as 5. Okay, which is given as 5. If we'll solve these equations, that is 3m plus 5 mod on root of 1 plus m square is equal to 5. If we'll solve this, we'll get the value of m as, two equations we'll get, because when we'll open the modulus, then it will open with plus and also with the minus. Then we are getting m as 1 is 0, another is m is equal to 15/8. And use these two slopes. Let's check what is the correct answer. Okay, put m is equal to 0 first, then it becomes y minus 1 is equal to 0, that is y is equal to 1. Then option B is the correct one. Yes, option B is correct one. And also put m is equal to 15/8. So by putting m is equal to 15/8, we are getting option A is correct, because the slope of this line is 15/8. Is that correct? Or is that understood to everyone? Simple or not? It's a JEE questions. Okay, mains level question. You can easily find the equation of tangents when you have an external point. Is that clear to everyone? Guys, shall I move to the next thing? Everyone respond to the chat box. It is clear to all. Okay, so let's move. Now how we can find the equation of normal? So actually, what is normal? A line is perpendicular to the tangent at the point of contact, then it is called normal. Always normal is perpendicular to the tangent. Okay, and in case of circle, we know the tangent is perpendicular to radius at the point of contact, right? We know all these things. Okay, so normal always passes through the center of the circle. Normal always passes through the center of the circle, like this. This tangent and normals are perpendicular to each other always. Okay, so this is my normal. So if you know how to find the equation of tangent, so you can easily find the equation of normal. Okay, because you know the slope of the tangent and also you know the center of the circle. So if the slope of tangent is m, then it will be minus 1 upon m. Slope of normal will be minus 1 upon m, right? So by using slope point form, you can easily find the equation of normal. This is the point you know, and this is the slope you know also, and you can use the center also as your point passing through. Is that clear to everyone? If equation of circle is given, clear? Okay, sure. Let's move. Now, how can you find the length of a tangent? What do you mean by length of a tangent? That is the length of tangent from the point, external point, to the point of contact. This is my length of. This is actually my length of the tangent. Yes. So if the equation of circle is like this, x square plus y square is equal to a square, then the length of tangent will be on root of x1 square plus y1 square minus a square. Clear? Everyone? Clear? Yes. So we can write this, the length of tangent is saying what is the length of tangent when the circle is given as x square plus y square is equal to a square, then the length of tangent will be x1 square plus y1 square minus a square. So what we are doing here? That is, if we'll take this as L, so we can write also L is equal to under root of S1. Yes or no? What is this? In under root, what you are having? S1 or not? What is S1? When you are putting the given point in the given equation. Yes or no? Equation suppose here we have here x square plus y square is equal to a square. Then by simplification, we are getting x square plus y square minus a square is equal to 0. So in the left hand side, if we'll put x1, y1, what you are getting? That is my s1. So s1 is equal to x1 square plus y1 square minus a square. So if s1 is this, then length can be on root of s1. Always remember what is s1. Now when you are putting the given point in the given equation, left hand side of the given equation, left hand side of the given equations, like that. Okay, so this is how we can find the length of the tangent. Okay, clear to everyone? And if it is a circle with center at origin, if I'll ask you to center at anywhere, then same formula, that is length will be on root of s1, right? On root of x1. That is, if you have the equation like this, x square plus y square plus 2gx plus 2fy plus c is equal to 0, then in the left hand side, put the given point in the left hand side. So what you are getting by putting the given point in the left hand sides, you are getting x1 square plus y1 square plus 2g of x1 plus 2fy1 plus c. Just take the under root. This is equal to, we can say, on root of s1. So length of the tangent is always on root of x1. Put the given external point in the left hand side of the equation of circle. So after putting what you are getting, that is my length. Is that clear to everyone? Guys, clear? Okay. Sure. Let's move. Now, power of a point with respect to a circle. What is that actually? Just see, the power of a point P with respect to any circle is PA into PB. That is PA into PB. The length of PA into PB is called the power of a point P with respect to any circle. Okay, by using the geometry, we can write also PA into PB is equal to PT square. PA into PB it is equal to PT square. Thus, the power of point is square of the length of the tangent to a circle from the point. That is also, we can say, the power of point is actually power of point is on S1, right? What is the equation you have? Suppose you have an equation of circle like this. Let's see. Suppose you have equation of circle like this, x square plus y square plus 2gx plus 2fy plus c is equal to 0. Then the power of point will be S1. That is, put the given point. If the coordinate of P is x1, y1, right? Then put it here. So S1 will be your power point. That is, S1 is equal to x1 square plus y1 square plus 2g of x1 plus 2fy1 plus c. This is my power point. Okay, you need to remember only S1 is the power of point. It's called the power of point. Okay, guys, everything is clear to everyone? Chalo, theek. Now we'll see what is the chord of contact. Chord of contact is actually the line joining the point of contacts. If you have an external point P and whose coordinate is x1, y1, if you draw two tangents to the circle, okay, if you draw two tangents to the circle and those tangents are touches the circle at the point A and B, then the line AB is called my chord of contact. The line AB is called my chord of contact. And the equation of how we can find the equation of chord of contact, that is T is equal to 0. Very simple, that is T is equal to 0. Suppose the equation of circle is given as x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay, then if you have a point, external point P whose coordinate is x1, y1, and from these points I have drawn two tangents to the circle, and those tangents touches the circle at the point A and B, right? Then what is the equation of chord of contact will be? That is, we know what is T. What is T? T is actually, but in place of x square, what do you have to substitute? That is xx1 plus, in place of y1, yy1 plus 2g into x plus x1 by 2 plus 2 into f into y plus y1 by 2 plus c is my t, right? Then this becomes simplify after simplification. What is it? Is becomes no, xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0, gives you the equation of chord of contact. That is t is equal to 0, equation of chord of contact. And you can say also, sir, in case of tangent also, we are taking the equation of tangent is t is equal to 0. But in that case, what is happening? In case of tangents, we are using t is equal to 0 is the equation of tangents when the point is on the circle. And at these points, we are drawing the tangents. So in this case, this is the equation of chord of contact. But sorry, this is the equation of tangent. But in this case, if you're drawing two tangents from an external point and you need to find the chord of contact, equation of chord of contact, that is in this case t is equal to 0. Here coordinate of p is x1 y1. It is lying outside the circle, but here in this case x1 y1 is lying on the circle. In case of tangent, this is the case of tangent and this is the case of chord of contact. Clear? Okay, don't be confused. Chalo, theek. So this is chord of contact, and now we'll see what is the equation will be of chord of contact when the midpoint is given of that chord. Okay, suppose here from origin we have a chord AB and the midpoint is given M. Midpoint is given, suppose x1 y1, midpoint is x1 y1. Then what will be the equation of AB? That is, equation of AB will be t is equal to s1. T is equal to s1. That means, what is that? T is equal to s1. Suppose you have equation circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Then t will be just replace in place of x square xx1, that is xx1 plus yy1 plus 2g into x plus x1, that is g into x plus x1 plus f into y plus y1 plus c is equal to s1. What is s1? Just put the point in the given equation of the circle and left hand side of the given equation of the circle. Okay, that is x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. So this is my equation of chord of contact when the midpoint is given. Okay, when the midpoint is given. Is that clear to everyone, guys? Is that clear to everyone? Yes. Sure. Now we'll learn how to find the pair of tangents. The equation of pair of tangent is s into s1 is equal to t square. Suppose you have equation circle, that is x square plus y square is equal to 0. Sorry, 4. Then what is the equation of pair of tangents will be? That is s. S means given circle s, that is x square plus y square minus 4 into s1, that is x1 square plus y1 square minus 4 is equal to t square, that is t square is xx1 plus yy1 square. So this is actually the equation of pair of tangents. So s into s1 is equal to t square. Remember always what is the difference between all these things. Okay, so s is actually the given circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is my s. And what is s1? Power of point, that is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. This is my s1. And what is t? By replacing x square as xx1, x square as xx1, y square as yy1 plus 2 into g x plus x1 by 2 plus 2 into f into y plus y1 by 2 plus c. This is my t. This is my s. This is my s1. This is my t. Remember, if you know these things, then you can find easily all the equations. Okay. So let's move now. What is directed circle? Director circle, what is it? So it is the locus of the point of intersection of perpendicular tangents. Suppose you have two perpendicular tangents like this. You have a circle, and this is my tangent, and this is, sorry. These are two tangents, those are perpendicular to each other. Then the locus of this point, intersection point, locus of this intersection point will be represented to the director circle, right? This will be the director circle. The blue dotted circle is known as my director circle. So in this is the case of circle. Actually, in case of circle, director circle will be this. When the tangents are perpendicular to each other and the point of intersection, locus of the point of intersection of those perpendicular tangents. Okay, so in case of circle, it always becomes a concentric circle. Concentric circle means circles having same center. And circles having same center is known as concentric circle. Okay, sure. Let's move. This is about director circle. Now the important portion which we have left with, okay, that is actually position of two circles to each other. Okay, position of two circles, relative positions of two circles. You need to understand this concept because from these concepts also questions are coming. Okay, guys. So let's see. Suppose two circles you have here, and those are not intersecting to each other. They have no point of contact. Okay, they are different from each other, and they have no point of contact. Non-intersecting case, then the line joining both the centers, C1, C2. Suppose the equation of first center of first circle is C1 and center of second circle is C2. Then if you join C1, C2, then what is the length you are getting between the centers of the both the circles will be greater than the sum of their radius. That is R1. Suppose in this case, R1 is this. This is my R2. Then C1, the length of C1, C2 will be greater than R1 plus R2. So how many tangents you can draw in this case? Now we can draw 4 tangents. How? Let's see. We can draw 4 tangents. This is one tangent. This is second tangent. Okay, this is my second tangent, and this is my third tangent, and this is my fourth tangents. So we can draw in this case when the two circles are non-intersecting, we'll get 4 tangents, common tangents, 4 common tangents. Okay. Now if two circles are touching each other at a point, okay, see, I'm drawing here the figure. When the two circles are touching each other at a single point, then in this case, if this is my C1, this is my C2, then C1, C2, length of C1, C2 will be sum of the radius. Okay, sum of their radius. And in this case, we can draw how many common tangents we can draw? We can draw 3 common tangents. Those are, one is this is one common tangent. Second, this is my second, and this is my third common tangents. Okay, so in this case, we can draw 3 common tangents. Clear? Okay, so the second thing is, if the circles are intersecting each other, okay, so then what is the case will be if these two circles are intersecting to each other. Okay, so what is the case actually? Now C1, C2, the length of C1, C2 will be lying between, see here, lying between mod of R1 minus R2 and less than R1 plus R2. That is the relation here we are getting. C1, C2, length of C1, C2 will be, sorry, greater than mod of R1 minus R2. If it is coming with negative, then we have to take greater than modulus, and it will be difference of mod of difference of their radius and less than r1 plus. So this is the relations you will get, and in this case you will get only two common tangents to the both the circles. Those are, one is this, second is this. Okay, in this case only we are getting two common tangents. But if if one circle touching another circle internally at a single point, okay, then what will happen? Then in this case, suppose this is my circle and another circle, it is inside, lying inside the circle, and it is touching the circle at a single point internally. Okay, so in this case, what will be the relation between the radius and the length between the centers? C1 C2 is equal to mod of R1 minus R2. Okay, this is the relation. C1 C2 is equal to mod of R1 minus R2, and in this course only we can run only one common tangent. Okay guys, in this case only we can run only one common tangent. Is that clear to everyone? And the last case is if the circle totally lying inside the circle, one circle totally lying inside the circle, then what is the condition? C1 C2, length of C1 C2 will be less than mod of R1 minus R2, and the number of common tangents will be 0. You can see here in this figure. Okay, clear everyone? Sure, let's move. Now, length of the tangents. Okay, so what is actually, there are two tangents also we should know. This tangent is called my direct common tangents. Okay, this tangent is called my direct common tangent, and to find the length of this tangents is actually on root of d square minus r1 minus r2 ka whole square. Clear? Okay, what is d? D is the length. D is the, what is d here? Anyone can say? D is actually the length between the centers. This is my d. Okay, so d is equal to, sorry, the length of the direct common tangent will be on root of d square minus r1 minus r2 ka whole square. This is my length of the direct common tangent, and it is called my transverse common tangent. Okay, this is called transverse common tangent, and the length of the transverse common tangent is actually on root of d square minus r1 plus r2 ka whole square. Okay, on root of d square minus r1 plus r2 whole square. So this is called my transverse common tangent. Okay, what is d here? The length between the centers, distance between the two centers, and this is my r1, this is my d, this is my r1, this is my r2. Clear? Sure. Now, when we can say two circles are orthogonal, if the angle between two circles is 90 degree, then the circles are said to be orthogonal. So how we can say both the circles are the angle between the two circles is 90 degree. That means the angle between the tangent of both the circle is 90 degree. Okay, instead of saying that, what we're saying, the angle between the circles means actually the angle between the tangents of both the circles is 90 degree. Then we can say those are orthogonal to each other. Both the circles are orthogonal. Okay, this is the case of orthogonal circles. Now, family of circles. Let's see. We can solve also questions. Let's complete the theory first, then we will solve questions. Okay, so what is family of circles? Like you can you have studied already in straight lines also, family of circles. Okay, sorry, family of straight lines also. So first case is the equation of the family of circles passing through the point of intersection of two circles. Suppose you have two circles, one is S is equal to 0 and another one is S dash is equal to 0. These are two circles and they are intersecting each other at 2 points. Okay, and passing through those 2 points, how many circles you can mean, so many circles, infinite number of circles you can draw, you know, by passing through these 2 points. See here, you know? So all these circles are called my family of circles when the circles are passing through the point of intersection of two circles. Okay, this is the first scenario. So how you can find the equation of this family of circles? That is same as s plus lambda into s dash is equal to 0. This is the equation represents to the family of circles. Okay, just put s and s dash. Okay, then try to find the value of lambda and put the value of lambda in this equation. Then what is the equation you will get? That is, so when what I'm trying to say to you, that is actually when you will change the value of lambda, then you will get a new circle. Here in this case, suppose if you put lambda is equal to 1, if you put lambda is equal to 1, you will get one circle, s plus s dash is equal to 0, right? If you put lambda is equal to 2, you will get another circle, that is s plus 2 s dash is equal to 0. So how you will change the values of lambda, you will get new circles. This is my called equation of family of circles, that is s plus lambda s dash is equal to 0. Then come to the second scenario. Okay, come to the second scenario. The equation of family of circle passing through the point of intersection of a circle, s is equal to 0 and L is equal to 0. That is, if you have a circle, S is equal to 0, and if you have a line intersecting to the circle, L is equal to 0, then the equation of family of circle will be S plus lambda L is equal to 0. That means those circles passing through these 2 points. Those circles passing through these two, sorry, this is one circle. It will say this is another circle. So this is when the line is intersecting the circle at 2 points, and by passing through those point of intersections, how many circles you can draw, that is called my family of circles also. And the equation represents here s plus lambda L is equal to 0. Clear, everyone? Okay. Okay, next come to the third condition, third case. What is the equation of family circle passing through two given points x1 y1 and x2 y2 can be written? Okay, suppose this is actually suppose you have the circle like this and you have a line, and which is represents to the diameter of the circle. Okay, and these 2 points are suppose x1 y1, x2 y2, and passing through all these 2 points, how many circles you will create? That is called my here family of circles. And here the equation is actually the what is that, diameter form of the line, x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus lambda into x x1 x2 y y1 y2 1 1 1. Okay, suppose I'm taking here any point here, any points here whose coordinate is xy, then then x1 y1 xy and x2 y2, these 3 points are collinear. So in which case it will be collinear, these 3 points will be, now when this determinant will be 0. So I'm taking the determinant of these 3 points into lambda is equal to 0. Okay, clear? Sure. Here also we can say s plus lambda L is equal to 0. Equation, determinant form and the direct diameter form of line and determinant form of the circle we are using. Here circle represents to determinant form and line is diameter form. Okay, is that clear to everyone, guys? Okay, let's move to the last thing, that is the equation of family of circle touching a fixed line. Okay, y minus y1 y minus y1 is equal to m into x minus x1. At the fixed point x1 y1, this coordinate of this is x1 y1 is this, that is x minus x1 square plus y minus y1 square plus lambda into y minus y1 minus m into x minus x1, that is s plus lambda L is equal to 0. This is my s, okay, s, this is my s, and this is my equation of line, okay. So s plus lambda L. So how the family of circles will be happening here? This type, passing through this point, passing through this point, okay, this point, clear? So this is my family of circles. So this is all about your family of circles, guys, okay. Okay, now I'm giving you one question. Okay, now tell me, if the question is JEE Mains 2019 ka question is the common tangent to the circle, common tangent to the circle x square plus y square is equal to 4 and x square plus y square plus 6x plus 8y minus 24 is equal to 0. Also passes to the point. We have to find also passes to the point. Option A, that is 4 minus 2. Option B, that is minus 6 4. Option C, that is 6 minus 2. Option D, minus 4 6. Try to find the point, the common tangent to the both the circles also passing through the point. Which of the following points it will be passing through? Okay, so take this question as your homework. Let's solve, try these questions after the class and come with the answer to the next class. So, okay, so we'll meet in the next class. Till then, bye bye, take care, everyone.